molecule. One would be is relevant to what hybrid atomic model is, and second is the relevant concept of VSEPR, that is VSEPR. So when we talk about hybrid atomic model, we deal with a theory of hybridization. Now, what this theory gives us is basically that whenever atoms they tend to form a bond, they kind of have different orbitals. We know it that these different orbitals may be s orbital, maybe p orbital, maybe d orbital, and when they kind of have to have a bond, these different orbitals they mix to form same orbital or identical orbital. So
Okay.
basically, this is relevant to something like this, that let's say if you're having H2 molecule. So we know this that each hydrogen contributes a single pair of electrons, right? So
Right.
H2 will have this electron that was supposed to be in the s orbital or the s subshell or the first shell of first hydrogen, and then this electron that was supposed to be in its own home is now somewhere in a unique place. So now what you need to understand is that, sir, inherently these two are different atoms, right? ये दो लोग थे जो अलग अलग घरों में रहते थे. So two separate homes.
Mm.
Now they are kind of pairing. वो अब एक साथ रहना चाहते हैं. So they need some readjustments, right? तो वो
Right.
रीएडजस्टमेंट क्यों की जा रही है भाई? इसलिए की जा रही है कि वो एक ऐसे घर में जाके रह सके जहाँ पे उनको जाहिर है इसकी कोई पर्सनल स्पेस में भी इसके भी नहीं. अब वो एक साथ रहना चाहते हैं एक घर में. तो दैट इज व्हाट दे नीड. तो केमिस्ट्री में इस कॉन्सेप्ट को हम कहते हैं कि क्या मिक्स हुआ है. एक एस मिक्स हुआ दूसरे एस के साथ और एक नया ऑर्बिटल बन. तो दैट इज बेसिकली व्हाट दैट इज अ हाइब्रिडाइज्ड ऑर्बिटल.
Mm-hmm.
And that was an S orbital. That was still in S orbital. अगर ये दो अलग अलग हाइड्रोजन थे और उन दोनों में एक एक इलेक्ट्रॉन बैठा हुआ थी, अब वो मिक्स हो गए. तो अब हम ये नहीं कह सकते कि ये जो नया वाला ऑर्बिटल है न्यूली मेड होम है ये इसका है या ये इसका है. ये इक्वल है और ये दोनों 50% पार्टनर है. और ये जो इलेक्ट्रॉन
Mm-hmm.
है जो इसमें दो इलेक्ट्रॉन है ये किसी एटम के नहीं है. दे बिलोंग टू अ नाउ मॉलिक्यूल. कुछ समझ आया मैंने क्या कहा?
Can you say that again?
मैंने कहा कि ये जो नए वाला एटम मतलब ये जो नए वाला ऑर्बिटल बना है दैट्स द हाइब्रिडाइज्ड ऑर्बिटल. ये इंडिविजुअल किसी का भी नहीं. दैट बिलोंग्स टू 50% ईच ऑफ द कंट्रीब्यूटिंग एटम्स एंड दैट बिलोंग्स टू द मॉलिक्यूल. इलेक्ट्रॉन पेयर इज नॉट नाउ रेलेवेंट टू atomic orbitals. It's somewhere in a new place. That is a molecular
Oh,
orbital.
okay.
अच्छा, अब इसमें बहुत सारी चीजें हैं जो हम इसको इस तरह से मैं समझाता हूँ से कि लेट्स से फॉर एग्जांपल मैं अपने दोस्त के साथ शिफ्ट हो रहा हूँ यूएस. ठीक है, अब मैं कहता हूँ कि यार मेरा अपना जाहिर है घर था यहाँ पे पाकिस्तान में, अपना घर था और जब दोनों साथ रहेंगे तो दैट वुड रिक्वायर व्हाट अ म्यूचुअल अंडरस्टैंडिंग ऑफ 100%, राइट? क्योंकि
Right.
अब हमें अपने अपने सब तौर तरीके छोड़ने पड़ेंगे और हमें कुछ करना पड़ेगा. तो मैं ये कहता हूँ कि चलो मेरे फार 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 फ्रेंड्स हैं जो पहले से यूएसए में सेटल है, मैं उनको पूरी कहानी सुनाता हूँ, उनको बताता हूँ. तो वो क्या करते थे, रेंट मी अ प्लेस एंड दे काइंड ऑफ रीअरेंज इट because they know me,
Right.
they know my requirements, they know that when someone comes from Pakistan, what he or she expects in a foreign land. So they kind of make some arrangements in that case. In my absence, I'm not right now there, but it has been, already started. So that is when an atom makes an arrangement to bond with the other atom. So then we say, okay, this is going into hybridization mode. Once that bonding is complete, as soon as I enter that room, I will find a new place, but I will find some few, kind of few features that are relevant to my household because people who arrange that know me very well. You get this idea?
Okay. Yes.
So when we say that that is basically a hybrid atomic model, what we mean to say is it's a very beautiful concept that two atoms are going to meet up for a bond. Okay, so no one, each of the atoms is not dominant atom. No one is a subordinate atom. They're equal partners. They're living in a place that is u- unique to each of them, but that kind of resembles somewhat the previous ones. So S is creating an S orbital. So now when I say S is creating an S orbital, what is that supposed to be? I am saying that individually it was an S atomic orbital. Now when they have collided, collapsed, merged, so now what we have is a S molecular orbital. Do you
Okay.
get this?
Yes.
So when we define hybridization, we say that it's basically a process of mixing of orbitals with different shapes and energies to form orbitals with same shape and energy, same number of orbitals with same shape and energies. Now that needs to be clear here. So right now you have discussed an example of S atomic mixing with another S atomic. So what do we have? We had a S molecular
Molecule.
orbital. So how is this different shape? We know this that S is a spherical shape, and this has to be another spherical shape. And as far as what we understand is, S molecule should be identical, right? So shape stays
Yeah.
same, but what changes is these they were high energy orbitals. Now, why is that they were high energy orbitals? Because electron revolving, sitting here is vacant. It desperately needs another electron. So bond banana, it has to complete its, two electrons. इसके पास तो एक ही है. That is unstable. That is why it is a high energy orbital. But that's not the case here. It has same shape, but it has a lower energy orbital. Make sense?
Yes.
So what would happen if there are, different shapes of orbitals? So let's say, so pehle to, this needs to be kept in mind that how many orbitals were mixing. So one orbital was mixing with another, right?
One orbital?
Was mixing with another, right? I'm having a
Yeah.
one orbital. So let's talk about if there is a mix of S with P. So now, as per our understanding, there are basically how many P orbitals? There are three P orbitals, right? Px,
Yes.
Py, and Pz. So when we say that there are three p orbitals, so this lead us to three different hybridization concepts. S might mix up with all three p's. S might mix up with two p's. S might mix up with one p. You get this part?
Yes.
So how many orbitals in total? So these are four, right? These are three. These are two orbitals.
Mhm.
Then
Yep.
so each of these four would now be labeled as a sp3, sp3, sp3 hybridized orbital. And each of this here would be labeled
SP.
as sp2, sp2, sp2. So there is practically no difference in the bonded orbital. So the newly
Oh.
bonded, electrons, they find themselves in an identical position. So let's do some examples of it. So when I say sp3 orbital, let's talk about what happens in methane. So methane is basically CH4. Okay. So if it is CH4, just a minute. Yeah, can you hear me? Hello?
Yeah, yeah. Yes, sir, I can hear you.
Just a minute.
Sorry?
Can you hear me?
Yeah, yeah.
Mute device and let it start me up. Okay, so methane. Let's talk about methane. So now we need to understand, okay, what type of hybridization does we have? So in any condition, we start with first the central atom. Whenever we are discussing what type of hybridization we have, so we need to identify central atom. So in methane, I see carbon and hydrogen. Now you tell me if it is one carbon and four hydrogen. So which one is the centralized atom? So that should be carbon, right? Why is
Carbon.
carbon? Because carbon offers four valencies. That is basically linked up to these four hydrogen. So carbon needs like basic ground where hydrogen can come. So that's the central atom. Okay. So let's focus on the electronic configuration. It has an atomic number 6, so it would be 1s2, 2s2, 2p2. So now if you know, if I draw this, that's the valence shell. So this would be 2s2, and then in P, we used to have Px, Py, and Pz. So this would be Px and Py, right? Pz is empty. So that is when you
Yeah.
say that carbon is no longer excited, it has nothing to do in life, it is basically in a ground state orbit. Now, why is this ground state? Because if that is what happens with carbon, no one can bond with carbon. Why? Because that is an empty orbital. कार्बन की अपनी
Yeah.
कोई एलिवेशन नहीं है यहाँ पे, ये कंप्लीटली फिल्ड है, ये दोनों एम्प्टी है। हमारे पास तो चार हाइड्रोजन है, तो चार हाइड्रोजन में से दो हाइड्रोजन यहाँ क्यों आएंगे, वो आपस में ही बॉन्ड बना लेंगे। So in order to welcome these up, what carbon do? Carbon, acts like that extended family of mind that's already settled. They rearrange it. It turn into an excited state. तो अब वो excited state में क्या होगा, guess? It would be something like this. One electron here, one electron here, one electron here, one electron. Make sense? So what happens is
Yes.
ये वाला pair टूट गया, यहाँ पे चले गए. Now what you see? I see four different vacancies, right?
Right.
And that four different vacancies can be occupied here by four different atoms. 1 year, 1 year, 1 year, 1 year. Right? So what happened here is this S mixed up with how many P's?
3.
So now they are welcoming something new. So that would be sp3, 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 sp3 hybridized orbital. So now no one can say this is S, this is P. No, they have mixed up. We get this?
Okay. Yes.
They were different shapes. We know it, right? S is a spherical shape, P is a dumbbell shape. So now they're mixed up and they've formed what? Same shape orbitals.
Okay.
Get it?
Yes.
So that is what an sp3 hybridization is. So if I discuss sp3, so there are four orbitals. We see this from the previous example. Four orbitals. Each has a 25% s character and 75% p character. That makes sense, right? Because I have to divide four into equal pairs. So one is S and three is P, right? Now, this
Yes.
shade would be tetrahedral. That means any substance, any element, any compound, any molecule that undergoes sp3 hybridization would have tetrahedral shaped molecules.
Okay.
And then the bond angles between them would always be 109.5 degrees. You get this?
Yes.
So now if we say that we have CH4, so carbon pi is now sp3 hybridized. So this is the way to draw sp3 hybridized orbitals. You see four different lobes. And P used to be something like this, right? So now what we're seeing is being mixed up with S. So what happens is, let's say, it mixes up here. So this would be something like this. So if it mixes up with the other side, what would happen? This would be the case, right? The other side. So what is happening? S is getting absorbed into P. So that's sp orbital. That was a p orbital, that was a s orbital, that's the sp orbital. So what you are not seeing is this part. So where does it went? It went somewhere right at the center. You get this?
Yes.
Then we say that these are bond angles. So these bond angles are with respect to each other. They're at 109.5. It kind of forms a pyramid, a tetrahedral shape. So this axis lies somewhere beyond my screen. So I'll show it to you later on, but this is what you need to understand for your exams. So very beautiful
Okay.
thing, if we go into minor details of it. But unfortunately, we have time and have to prepare for exams. Now, where is the hydrogen part? Okay, we see that there is one electron welcoming here, one electron welcoming here, one electron welcoming here, welcoming here. Hydrogen is still missing. So now we say that hydrogen would come here and attach the s orbital of hydrogen here.
Okay.
So now, how can I know that, sir, hydrogen would be s orbital? I have the configuration in my mind. Hydrogen is basically 1s1. So what I have drawn previously was carbon that has now the excited state configuration of one electron in each of these sp3 hybridized orbitals. Now it is bonding to hydrogen. So let's not draw orbitals here. Let's simply write hydrogen. So that shows a bond. H bond here. एक मिनट ईमान
Okay.
हाँ भाई तो where was I? Yeah, hydrogen here, hydrogen here, hydrogen here. So now essentially you understand that where this S is coming from.
Yes.
So this would be an
From the hydrogen.
bond, S sp3 bond, S sp3 bond. So sp3 and S. So S and sp3. Is this clear?
ठीक है. Yeah.
We understand?
Yes. Yes. Yes.
Then we have a few different scenarios. Maybe let's discuss shape of ethane. So ethane is C2H6. Okay, so if we talk about the central atom, we know it would be what? Carbon. And what we see is that each carbon is associated to 3 hydrogen, right?
Right.
So there are basically two CH3 groups that are bonded together here. So basic configuration would still stay same. That means, carbon, if it is in the excited state, it would be something like this. So let's redraw it. This is basically carbon, the central atom behavior. You don't need to draw this in your exams. It would be, by default known to you. अब मैं आपको समझाने के लिए बना रहा हूँ, आपको बार-बार नहीं बनाना. So this happens for this. 1, 1, 1, 1. And what are these? Are these hybridized orbitals or unhybridized orbitals?
Hybridized.
Hybridized. Great. Hybridized orbitals. So all are sp3 hybridized, right? Then we have each of these orbitals connected with one hydrogen. Okay, that is then one hydrogen comes, that is one hydrogen comes, that is one hydrogen comes here, and one hydrogen here, one hydrogen here, one hydrogen. Make sense? Now think for a second.
Yes.
Okay, sir, if this happens, then this is still empty, right? So how would you kind of readjust this? So what I can say is, if this CH3 group decides to link its sp3 hybridized orbital with the vacant sp3 hybridized orbital here, right? That is a possibility because these both the groups, they are having one empty slot available. Make sense?
Yes.
So what can happen? So this can happen. CH3 banate happen. So CH3. That is what we did, right? Then hydrogen here, then hydrogen here, then hydrogen. So essentially, it's the exactly same, right?
Yes.
But here, I'm not attaching hydrogen. Why is that so? Because there is no hydrogen left. There were 3 hydrogens, so all these 3 are here. Hydrogen 1, hydrogen 2, and hydrogen 3. So what comes here? The entire, CH3 group comes here. So let's say that's the other C. Let's
Okay.
bear this in mind that that's the other C. So that is still sp3 hybridized. So they have linked with each other in this.
Okay.
So it has carrying its own hydrogen. Make sense?
Yes.
So that would be an sp3s overlapping or bonding. Right? Rest would be S and sp3. S and sp3. You understand this?
Okay. Yes.
मेरा बहुत दिल चाहता है कि मैं बच्चों को ना ये दिखाऊं. तो एक्चुअली दिखाना तो बड़ा आसान है कि मतलब उसको डिजिटल दिखा दे, लेकिन आपको तो कैमरेज में देना है ना, तो फिर मुसीबत तो वही आ जाती है कि यार आपको तो पेपर पे बनाना है, राइट.
Yeah.
तो अब मैं आपको दिखाता हूँ ताकि आपको थोड़ा अंदाजा हो क्या है, ये हो क्या रहा है, मजाक क्या हो रहा है, किस किस्म का हो रहा है. बट इवेंचुअली यू हैव टू कीप दिस थिंग इन माइंड कि इसकी पिक्चर देखने का कोई इतना फायदा इसलिए नहीं है बिकॉज और शुड हैपन, हमें तो वो बनाना पड़ेगा, हमें वो बनाना आना चाहिए. अब हमने वो बनाना सीख लिया, अब हम पिक्चर देख सकते हैं जस्ट फॉर मोर क्लैरिटी. ठीक है, तो आपके
Okay.
लिए आप ये दिखा सकते हैं. तो अच्छा लगता है. Do you see this?
Yes.
So the black one represents what?
Methane molecule.
That is a methane molecule, and the black one is the carbon atom. The white ones are.
Sorry?
I said that's a methane molecule. That is correct. Okay, that we know.
Yeah.
But in methane, this represents what? The black colored one. Carbon.
Carbon.
And these small ones, these are hydrogen. Make sense?
Hydrogen. Yes.
You get this part?
Yes.
So that is what it's supposed to be like in a three-dimensional space, with a perfect set of drawing skills and all. But we are not required to go into that because Cambridge doesn't want it, it's a bit easy to understand it this way. So people they
Okay.
draw it like this too. So this happens. You get this part?
Yes.
Okay. So let's come back.
So the last drawing you made was also tetrahedral?
Sorry?
It's the last drawing you make, that was also tetrahedral?
Yeah, that if it is having an sp3 hybridization, so it should be tetrahedral.
Okay.
So it was supposed to be something like this. Can you see my screen?
It's, yeah. Yeah.
So we have kind of GIF image here. It's not offering that here. Why not do it? Yeah, that is awesome. So eventually this is to be there. That is a very good save.
Yes.
Okay, so coming back to where were we? So that is ethene. So then we can have even sp2 hybridization. We can also have sp hybridization. So when do we have sp2 hybridization? When we have one double bond. And when do we have sp hybridization? When we have a triple bond.
Okay.
So what would this be looking like? It would be something that happens in C2H4. So that is ethene. So central atom is still carbon, but you can see that each carbon would now be associated to two hydrogen. So if in order to satisfy its, the complete tetravalency, carbon can form a single bond, but still they have one more valency left. So they bond another, hydrogen base group. So what happens here in sp2 hybridization? I'll have one S combined with two P. So that would make up sp2 hybrid atomic orbitals, and then sp2 hybrid atomic orbitals would be basically 3 in number.
Yes.
And then each will have 33.33% S character and 66.66% T character. That adds up to 99.98. That is assumed to be correct. So shape would be planar trigonal.
Pyramidal.
No, angle would be 120.
Okay.
And then we are left with SP. So SP would be something like 1S combining with 1P. So that would be 2 in number.
Yes.
And since there are only 2, so 50% would be S properties and 50% would be P properties. So that's the shape of a linear structure, and angle would be 180 degrees.
Okay.
This part.
Yes.
So now what I would be doing is I would be sharing some images. I won't be drawing them, so that you know what happens here. So C2H4. Let's have a look here. That's one of the best parts. C4. So that is what happens in basically C2H4. So all of these shapes, like something like
Okay.
that. So now what happens here is there is something missing, right? So that missing part is, if you see here, this is basically sp3 hybridization happening here. They are bonded to each other, but that is one P which is left alone. Now, why is it left alone? Let's discuss that, what we have discussed previously. So this was one carbon having, 4 electrons, right?
Yes.
Now what happens is that this connects with hydrogen. That makes sense. This connects with hydrogen. That makes sense. Now these two are involved in bonding. Okay, fine. But when we talk about these two, so this is basically carbon being connected to 2 of the orbitals. Make sense?
Yes.
Hello,
Yes, sir.
you get this part?
Yes.
Now, if we talk about that, why is this remaining unhybridized, or why is this not involved in any shape? So you need to understand that that was a single bond, right? That was
Yes.
the first bond was a single bond, but this is what it made a double bond, right?
Okay. Yes.
So it's like कि मैं अपने दोस्त के साथ बाहर जाके रहना चाहता था, अब साथ में दोस्त अपने साथ भी किसी को ले आया, so that guy is not welcome there, right?
Uh-huh.
So I am not, making any arrangements, any specific, compromises for that guy. We get this part?
Yes.
So it kind of is weird because कार्बन ने हाइड्रोजन के साथ बॉन्ड बनाना था, कार्बन को अपने 4 के 4 पूरे करने थे. ओके, कार्बन ने कहा कि ठीक है चलो बना लेते हैं, बट कार्बन को ये नहीं पता था कि अपकमिंग कार्बन मेरे साथ एक डबल गेम खेलने वाला है, मेरे साथ वो एक और मतलब बाय वन गेट वन का सिनेरियो कर रहा है. You get this part?
Yes.
लेकिन वो इतना बेवकूफ है कि भाई अगर तुम इसको छोड़ दो, लेट्स से if we erase this, let's say forget about this, then what happens? भाई फिर भी तो तुम्हारा एक बैलेंस ही रहेगा ना, खाली रहेगा ना.
Yeah.
सो अगर आपका जैसे मेरा रूम था वहां पे, भाई मुझे रूम शेयर करना पड़ गया, मेरा दोस्त किसी को ले आया, तो इसमें अपसेट होने वाली क्या बात है? लेकिन अरेंजमेंट्स आर नॉट देयर. जगह थी
Yeah.
लेकिन अरेंजमेंट्स आर नॉट इन प्लेस. So that
Okay.
came as a surprise कि भाई अच्छा जगह थी, तो उसने सोचा मेरे दोस्त ने कि चलो मैं अपने किसी दोस्त को ले आता हूँ तो वो एक रूम में रह रहा है, बट हमने कुछ अरेंज नहीं किया था उसको, क्योंकि हमें पता ही नहीं था कि भाई वो आने वाला है. सो अगर हम उसको ना भी अलाउ करें तो हमारा एक जो जगह है वो खाली है, राइट? एम्प्टी स्पेस इज देयर, बट for the sudden entry of that guy, that is what creating problem. Do you get this?
Yes.
So now that sudden
Yes, sir.
needs to be understood in terms of an entirely new harm. Let's talk about
Okay.
what's that. That is basically what pi bond is.
So if we are asked about this question that why isn't hydrogen attached with this carbon, so what will we say like in written form?
So yeah, okay, let's start discussing that. Why do this? Carbon is being attached to hydrogen. So in order to complete its duplet, they need to valence electrons. So they are forming a single covalent bond. So they in that way they become stable. That is why they are attaching themselves to the carbon.
Okay.
Okay. So now that's the surprising element here. So whenever there is a double covalent bond, तो पहले तो ये ज़हन में रखो कि double covalent bond क्यों बनता है? Double covalent bond बनता है मजबूरी में. So let's write out of necessity बनता है ये. जरूरत में बनता है. ये कि कोई अच्छी चीज नहीं होती. क्यों नहीं होती अच्छी चीज?
Okay.
Because atoms चाहते हैं कि वो multiple bonded हो, different atoms के साथ bonded हो. एक ही जगह पे बार बार नहीं बॉन्ड होना चाहते हो. तो अब अगर एक
Okay.
कार्बन को हमने कहा कि ओके उसमें डबल बॉन्ड बना हुआ है, तो अगर लेट से उसे एक हाइड्रोजन और मिला यहाँ से गुजरता है, तो वो फौरन ही अपना ये बॉन्ड तोड़ेगा और उसको पकड़ लेगा कि भाई तुम आ जाओ इधर. We get this part?
Yes.
So now what we need to understand precisely is double covalent bond is not something not good. That shouldn't be happening. Okay. So double covalent bond को केमिस्ट समझाने के लिए टर्म यूज करते हैं पाई बॉन्ड. So now they divide covalent bonds into two types. Covalent bond
Okay.
that is more stronger, that is more needed, that is more stable, required है, stable है. That is what they say a sigma bond. Sigma बंदा है, sigma male है, strong है.
जी.
मोर स्ट्रॉन्गर नहीं होगा तो वो लेस स्ट्रॉन्गर होगा फिर दूसरे वाला. और रिक्वायर्ड नहीं होगा, फजूल में बन रहा होगा, आउट ऑफ नेसेसिटी बन रहा है, मजबूरी में बन रहा है, जाहिर है अनस्टेबल होगा फिर, तो वो क्या होगा? दैट इज अ पाई. So that hybrid
Okay.
atomic model assumes that all orbitals which are either empty or involved in pi bonding. वो जो मैथ्स वाला पाया है ना, ये वो वाला पाया है.
Yeah.
They remain unhybridized. उनको हाइब्रिडाइज होना ही नहीं है. अच्छा ठीक है, नहीं होना तो क्या करें फिर? तो ये करते हैं फिर. हमने कहा एक कार्बन था, उसके पास सबसे पहले तो नेचर ऑफ हाइब्रिडाइजेशन हो गई sp3. तो उसने दो हाइड्रोजन लिंक कर लिए. दैट इज CH2, राइट? दिस इज व्हाट शुड हैपन.
Yeah.
एक कार्बन के साथ दो हाइड्रोजन आ गए. दूसरे वाले ने भी इसके साथ यही गेम किया तो वो भी यहाँ पे आ गया. ओके, ठीक हो गई बात, ये बन गया. अब क्या मसला है? अब मसला ये कि इनका एक एक पी ऑर्बिटल फ्री है. तो वो फ्री ऑर्बिटल ने यूं करके बनाते हैं, दिखाते हैं अनहाइब्रिडाइज. अब वो क्या करते हैं, उसमें भी इलेक्ट्रॉन है, उसमें भी इलेक्ट्रॉन है, इसमें भी इलेक्ट्रॉन है, इसमें भी इलेक्ट्रॉन है. तो वो क्या करते हैं, अपने आप को ना एक दूसरे की तरफ बेंड करते हैं. तो लेट्स ड्रॉ इट स्टेप बाय स्टेप. मैं बाकी नहीं बना रहा, मैं तुम्हें सिर्फ ये दिखाना चाहता हूँ. ये टिल्ट होते हैं एक दूसरे की तरफ. दे ट्राई टू रीच out to each other, something like this.
Okay.
Then they merge like this.
Oh, okay.
बॉन्ड तो बनाना है ना उसे मजबूरी में, उसने ऐसे बना लिया.
Yeah.
मतलब ऐसे बता रहा. एंड देन दे कंप्लीटली डिसअपियर. इनकी एंटिटी खत्म हो जाती है. इट्स लाइक दिस. तो अब ये वाला
Okay.
इलेक्ट्रॉन यूं घूम सकता है इसके अंदर, ये वाला इलेक्ट्रॉन यूं घूम सकता है इसके अंदर, बट दे कैन नॉट पास थ्रू दिस. दैट्स इंटर न्यूक्लियर एक्सेस. इट्स काइंड ऑफ इन LOC, जिसमें कोई बॉर्डर मूवमेंट को पॉसिबल नहीं है, इलेक्ट्रॉन यहाँ नहीं जा सकता. So pi bond basically is a parallel bond, sideways bond. Sigma bond was a headways bond. अब वो headways कैसे था? So let's write it headways. Headways इस तरह से था, remember मैंने कहा था कि एक ऐसा आया और वो दूसरे P के साथ head on चला गया. क्या हुआ फिर? ये हुआ भाई, ऐसा हुआ. जाके एंट्री हुई उसके
Yeah.
अंदर, कोलिजन था. लेकिन पाई में ऐसा नहीं हुआ. पाई में वो मजबूरी के साथ ही जो है ना. तो मैं बच्चों को जब
Okay.
समझा रहा होता तो आई गिव देम एग्जांपल लाइक दिस के अगर जैसे हम ईद पे गले मिलते हैं तो दैट इज व्हाट अ सिग्मा बॉन्ड इज. वी लव पीपल, वी hug each other on and that kind of creates what what we say happiness and all.
बट अगर हम किसी से मजबूरी में मिलते हैं ना, तो हम कोशिश करते हैं कि हम हाथ मिलाएं। यू गेट दिस पार्ट?
Yeah.
तो अब उसने अप्रोच किया था मुझे गले लगाने के लिए, लेकिन आई डोंट वांट टू मीट दैट इन, तो मैं उसको इतने भी चलो गले लगा लूंगा, तो मैं लगाऊंगा थोड़ा साइड करके लगाऊंगा ना उसको। ये मतलब
Yeah.
ओवरवेलमिंग नहीं दूंगा मैं कि मतलब हाँ भाई वाह, मैं जैसे अपने भाई से गले मिला तो मैं तेरे से भी नहीं वैसे होना नहीं चाहिए। मतलब बिल्कुल गलत बात है, अगला आपको अप्रोच कर रहा है, लेकिन मैंने उसको या तो गले साइड से लगाया, हल्का सा लगाया, या हाथ मिला लिया, अपना हाथ पहले आगे कर दिया, यू नो, इन ऑर्डर टू,
Yeah.
क्या कह सकते हो उसको, वो उस इतने ओवरवेलमिंग लव से बचने के। दैट इज व्हाट बायस,
Okay.
यू नो, हेड में अपने लोगों के साथ
Okay.
दोस्ती, फ्रेंडशिप। डू यू गेट दिस पार्ट?
Mm-hmm. Yes.
तो नाउ व्हाट आई वुड रिक्वेस्ट यू इज कि आप अपनी जो आपके पास बुक है ना, वो ब्लू वाली,
Yes.
जरा उसको खोलो, इस्तेमाल करो थोड़ा, किताब को रखो।
Just a second.
उसकी पीडीएफ है आपके पास?